In this video, we will study the derivatives of the 6 trigonometric functions. We first consider the derivative of sine of x. So this is the limit as h goes to 0, sine of x plus h minus sine of x all over h. Now, using a property of trigonometric functions, we can rewrite sine of x plus h as sine of x times cosine of h plus cosine of x times sine of h. Now let's factor out a sine of x. And we'll be left with cosine of h minus 1. I'm also going to write this as two fractions. Then plus cosine of x times sine of h all over h. Right, we can write this as two limits. In the first limit, let's factor out that sine of x since it's constant with respect to h. And we're left with cosine of h minus 1 all over h. From that second limit, we can factor out the cosine of x, again, because it's constant with respect to h, and we're left with sine of h over h. Now, you should recognize these two limits. These are special limits that were derived back in the video on indeterminate forms. Limit of cosine of h minus 1 over h is 0. Limit sine of h over h is 1. So what we find is the derivative of sine of x is cosine of x. We next consider the derivative of cosine. Again, we shall use the limit definition. So it's the limit as h approaches 0, cosine of x plus h minus cosine of x all over h. We will again use a trigonometric identity to write cosine of x plus h as cosine of x times cosine of h minus sine of x times sine of h. Doing the same thing we did for sine, we will write this as two fractions. The first fraction will be cosine of x times cosine of h minus 1 all over h. The second fraction will be sine of x times sine of h all over h. This is now two limits. We can factor out a cosine of x. We're left with limit as h approaches 0, cosine of h minus 1 all over h. Minus, we can factor out a sine x, and we're left with the limit as h approaches 0, sine of h over h. And just like in the derivation of sine, that first limit is 0, that second limit is 1. And so what we find is that the derivative of cosine of x is negative sine of x. Next, we consider the derivative of the tangent function. We will not use the limit definition here. Instead, what we can do is rewrite tangent as sine of x over cosine of x. Now we can just use the quotient rule since we know the derivatives of sine and cosine. Right? Quotient rule, denominator, times the derivative of the numerator, minus the numerator times the derivative of the denominator all over the denominator squared. Simplifying the numerator, we're going to have cosine squared x plus sine squared x. All that will be over cosine squared. However, cosine squared plus sine squared is a Pythagorean identity. That is equal to 1. And so what we find is that the derivative of tangent of x is equal to secant squared of x. Now we consider the derivative of the secant function. Again, we will not use the limit definition. Instead, we will write secant as 1 over cosine of x, or as cosine of x to the minus 1. Now this is a simple power chain rule, right? So it'll be negative cosine of x raised to the negative second power times the derivative of cosine of x. This gives sine of x over cosine squared x, which can be written as sine of x over cosine of x times 1 over cosine of x. And so we find that the derivative of the secant function is tan x times secant x, or often written as secant x times tangent x. Now let's look at the derivative of the cosecant function. So cosecant can be written as 1 over sine, or again as sine of x to the minus first power. This will give us negative sine of x to the negative second power times the derivative of sine. This will leave us with negative cosine of x over sine squared, which can be written as negative cosine x over sine of x times 1 over sine of x. And so the derivative of cosecant x is negative cotangent x cosecant x, or more commonly written as negative cosecant x cotangent x. The last function to consider is the derivative of the cotangent function. Cotangent can be rewritten as 1 over tangent, or tangent of x to the minus 1 power. This will be negative tangent of x to the minus 2 times the derivative of tangent, which is secant squared. We can write this as negative cosine x over sine squared x times 1 over cosine squared x, which is negative 1 over sine squared x. So the derivative of the cotangent function is negative cosecant squared. In summary then, just to have all these written in one place, derivative of sine of x is cosine of x, derivative of cosine of x is negative sine of x, derivative of tangent of x is secant squared of x, the derivative of secant of x is secant of x times tangent of x, the derivative of cosecant of x is negative cosecant x cotangent x, and the derivative of cotangent x is negative cosecant squared of x. These are our 6 trigonometric derivatives. And as always, we shall conclude this video with several examples. Let's start by considering the function f of x is equal to 5x cubed times sine of x. To find f prime of x, the overarching rule is product. This is a product of two functions. So product rule said we take the first derivative, the first function, multiply it by the derivative of the second function, add the second function times the derivative of the first function. Simplifying this, we can factor out a 5x squared, and we'd be left with x cosine of x plus 3 sine of x. Now, let's consider the function f of x equals cosine of x over 4x squared. Now, to find the derivative of this function, we need to use the quotient rule. Right? This is a quotient of two functions. So it's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. We can factor out a negative out of this. We can also factor out a 4x, and we'd be left with x sine of x plus 2 cosine of x all over 16x to the fourth. Now, that 4x and that 16x to the fourth will simplify. Right, so we'll have negative x sine of x plus 2 cosine of x all over 4x cubed as our derivative. Next, consider the function cosecant x plus x tan of x. Now this is a sum of two functions, so we're going to use the sum rule. So f prime of x will be the derivative of the first function, which is negative cosecant x cotangent x, plus the derivative of the second function. Now the second function is a product rule. First times derivative of the second plus second times derivative of the first. Now just to write this in a more aesthetically pleasing form, we can write x secant squared x plus tan x minus cosecant x cotangent x. It's just my personal preference to have negatives occur at the end of the function whenever possible. And as our final example, let's consider finding the 74th derivative of sine of x. Now remember, 74th derivative is the derivative of the 73rd, right, which is the derivative of the 72nd. So let's just start calculating. So derivative of sine of x is cosine of x. So the second derivative of sine of x would be the derivative of cosine, which is negative sine of x. Right? Then the third derivative of sine of x would be the derivative of negative sine, which is negative cosine. And the fourth derivative would be the derivative of negative cosine, which is sine of x. At this point, we can stop, right? We've gone back. After 4 derivatives, we've returned to the original function. So to evaluate the 74th derivative, try and write 74 as a multiple of 4. Well, 74 isn't, but 72 is. And since 74 is 2 plus 72, we can say this is the second derivative of the 72nd derivative of sine of x. And since 72 is a multiple of 4, that's just sine of x. So this becomes the second derivative of sine of x. And looking at our chart, that is negative sine of x. So 74th derivative is negative sine of x. So that concludes this video on trigonometric functions. The next video in this series will deal with derivatives as rates of change.